Good morning, good afternoon, and good evening. Welcome back to Chapter 3. We're talking about the organic molecules that make up life. We said there are 4 organic molecules: carbohydrates, proteins, lipids, and nucleic acids. Let's talk about our first one, carbohydrates. Carbohydrate means carbon plus hydrogen plus oxygen. And I'll show you just a minute where all those things go. But carbohydrate, that's what it means. So it's carbon, hydrogen, and oxygen. If you look at the paper, you see the 1 to 2 to 1 ratio. Carbohydrates are made of CHO, carbon, hydrogen, and oxygen. It is specifically in this very specific ratio of 1 to 2 to 1, which means when you have any sugar molecule, any carbohydrate molecule, the formula is always going to be in this 1 to 2 to 1 ratio, which means if I know that there are 6 carbons in my carbohydrate, how many hydrogens am I going to have? 12. And how many oxygens am I going to have? 6. 1 to 2 to 1. C6H12O6 is the formula for a lot of different sugars. There's C5H10O5. That's a different sugar. Okay? Carbohydrates are made of CHO, CHO, carbon, hydrogen, oxygen, in this very specific ratio, 1 to 2 to 1. Carbohydrates are sugars and starches. So cornstarch is a carbohydrate. Table sugar, what you put in your sweet tea, is a carbohydrate. These things, sugars and starches, are carbs or carbohydrates. So if you hear about like a low-carb diet, they're saying a low-carbohydrate diet. Our first, one last thing about carbohydrates is that they are rings of carbon. And I'll show you a picture in just a minute of what I mean by a ring of carbon. Our first carbohydrate is a monosaccharide. Mono means one, sac will take it to mean sugar ring. So monosaccharide means one sugar ring. Examples of monosaccharides are glucose and fructose. First, what do you notice about those names? You probably notice that they have the same ending, ose. One of the cool things about organic chemistry is that different types of molecules all have the same endings, or rather, each molecule within a particular group will have the same ending. So, what do you think ose means then? Ose means sugar. If anything ends in ase, A-S-E, it means enzyme. So like peptidase or alcohol dehydrogenase. ACE means enzyme. If it ends in OL, all, it is an alcohol, like butanol or isopropyl alcohol or ethanol, OL, all. So the cool thing about organic chemistry is each different class of molecules will always have a very specific ending that tells you exactly what kind of a molecule it is. Anything that ends in OSE is a sugar. Monosaccharides fuel, oh god, most of the things in your body. Your body really likes to burn sugar, which is why we love sweet things. Your brain demands sugar. Your brain insists that it gets sugar. And so if you don't give your body sugar, it will take what you give it and turn it into sugar. That's not a cheap or easy process. It's actually quite metabolically expensive to turn something that's not sugar into sugar, which is why low-carb diets work, because they make you waste energy by converting non-sugar things into sugar. We use the raw materials in these, our carbohydrates, to make other molecules that we need. So this shows that sugar ring. This actually shows the 3 different ways of drawing the same molecule. This right here is glucose. This is C6, 1, 2, 3, 4, 5, 6. H12, 2, 4, 6, 8, 10, 12, O6, 1, 2, 3, 4, 5, 6. C6, H12, O6. This is glucose. This is a ring of carbons. Like we said, it's a carbon ring. And this is what makes it a sugar, is the fact that it's a carbon ring with that oxygen right there. This is the structural formula. It shows you exactly how it's created, exactly how it's made. You can understand that it would take a long time to draw all of these things on a piece of paper, like if you're taking notes in a chemistry class. And so you go from the structural formula, which shows you everything, to the abbreviated structure. And the abbreviated structure is similar. It just doesn't show where the carbons are. You just assume that if there's an angle there, that there's a carbon. Okay? Well, drawing all those H's and OH's can get to be a pain in the butt. So because I know I'm drawing an organic molecule, I will just assume then anywhere there's an angle, there's carbon with hydrogens and hydroxy groups on it. So this is that simplified structure that we talked about when we saw the lions. This is that simplified structure. This, and we're actually, I hate to do this to you, we're going to use this structure more than anything because it's just simple to draw. It's easier to draw. It's faster to draw. So you just assume that there are other molecules attached at these carbons that we're just not going to show. And most of the time, for our purposes, this is a non-majors class. For most of the time, for our purposes, it is not critical to know exactly that there are hydroxy groups and hydrogen groups. But understand that they are there, and we're going to revisit this again in a number of chapters. Those are monosaccharides, one sugar ring. Now I'm going to make a disaccharide. Let me go back to that picture. Let me show you how we're going to make a disaccharide out of two monosaccharides. So what I do is I'm going to take and cut off the OH group from one of these molecules. I'm going to cut that hydrogen off right there from this OH group. H plus OH is going to make what? It's going to make water. And then where this oxygen is supposed to have another bond right there, I'm going to take and draw a bond between this oxygen and that carbon. I've cut this thing off completely, so this carbon's missing a bond. Oxygen gets two bonds. There's one, there's the second one. I've removed one of those bonds to make my water molecule, and where that was, I'm going to take that bond and draw it up there. So now if we flip to the next slide, we can see here's that lone oxygen in the center. Those are those carbons right there that we just talked about, and this is now how they're linked together. That was dehydration synthesis. I removed a water molecule and then made a bond between where those bits of the water molecule had been. This right here is sucrose. It's a what kind of molecule? It's a sugar. How do I know it's a sugar? Because it ends in OSE, sucrose. This particular sugar is what you put in your Kool-Aid. This is what you put in your sweet tea. This is what you put in your coffee. This is what you use to bake cookies with. Cookies. I want some cookies now. All right. Sucrose is a disaccharide. Di means what? Two. Disaccharide means two sugar rings. Here are my two sugar rings. These two sugars specifically, if you look at them close, they're actually slightly different. These two sugars specifically are glucose and fructose. Notice how fructose is a 5-sided ring and glucose is a 6-sided ring. Fructose is actually a lot sweeter than glucose. It's actually a lot sweeter than sucrose. Sucrose, like I said, table sugar. Table sugar is sweet. Fructose is a component of sucrose, and fructose is actually sweeter. So if you look at the back of a soda can, we see right here high fructose corn syrup. This is why pretty much any sweetened sugary drink, if you look at the back of it, they're all the second ingredient. The first ingredient is always going to be water, but the second ingredient is always going to be high fructose corn syrup. Fructose is very, very sweet. Again, sucrose, 2 rings, table sugar. Next are polysaccharides, and let's talk about polysaccharides in the next video.